So it looks like I've got a recording, I'll find out where that recording is after, and I will post it. So first thing I want to do is I want to just start and see if anybody has any questions before I get going forward with the problems that I posted to Blackboard. Does anybody have any like general questions about anything they want to me to go over or anything like that?
No, I'm all right.
Okay. All right. So let me go over what's going on this week. So on 331, the lecture here, you're going to learn about something called the sampling distribution for the sample mean. Now this is kind of like a new topic for you. And just out of curiosity, has anybody taken a look at the lectures for that yet?
Not yet.
That's okay.
No, I haven't.
All right. That's all right. So I have two problems I'm going to work for you today. The first question that I have worked is not related to the sampling distribution of the sample mean, but the second problem I have here today, I am going to show you how to use the, or talk a little bit about the sampling distribution of the sample mean. So then on the 4/02 tab, you're going to learn a little bit more about the sampling distribution and sample mean. And then you actually have your first quiz or first online quiz of the class. Has anybody downloaded and looked at the quiz yet?
Yeah, I've looked at them.
So I highly encourage you immediately after class today to download the quiz and try it. So question number one, I'm not going to go over on this lecture, but if you look under the 3-26 tab of the classroom, there's this table called the ztable.pdf. You're going to need that table to answer the first question. And there's a bunch of videos on how you read the table. After this lecture today, you'll be able to do problems number 2 and 3 very, very easily on the quiz. And actually, if you've looked at the quiz, problem number 2 should look very similar, perhaps, to some of the problems I'm doing today. Wink, wink. I don't know if anybody has any idea about that. But so then under the 4-2 tab, you'll have your first quiz. And then the way you'll want to submit it is you can either download the PDF and write your answers in and then scan them or take pictures of the solutions, or you can download the Word document and type in your answers and submit it that way. Okay. All right. For a little bit of background noise, if you're not speaking, if you could just mute your mic, I'd appreciate that. I muted you, just a little bit of the background noise there. Okay. So how many people, you can either type in the chat or, talk a little bit if you're not gonna have too much background noise, but how many people have their graphing calculator with them handy today? Well, I hope you have your graphing calculator today, because what I want to do in this lecture here is I want to show you how to answer these problems like super easily with your graphing calculator. Okay, I'm going to use the TI-84. I'm also going to show you how to use a TI-83 to answer these just once, but the TI-84 is a little bit easier for answering these. Okay, so let's take a look at this first problem here, okay? Let me load up the first problem. Question 1, okay? So in a study of 2003 study, the Accreditation Council for Graduate Medical Education found that medical residents, this is important, mean hours worked per week was 80 hours. Does that seem like crazy to everybody that on average they're working 80 hours a week?
Yeah.
Yeah, I couldn't even imagine that. It's like 2 full-time jobs. It goes on to say, suppose the number of hours worked per week by medical residents is normally distributed. Okay, so that's another important feature here, normally distributed with a standard deviation of 5.5 hours, okay? So the next question says, what is the probability? So I'm asking you a probability question. that a randomly selected medical resident works more than 84 hours per week. Okay, so here's the whole concept of this. If I'm going to select a medical resident at random, do I know exactly how many hours they're going to work per week? Like, just go ahead. Like, just if I grab a doctor at random, do I know how many hours they're going to work per week? Like, no, I have no idea, right? That's just a randomly selected doctor. I have no idea. So I'm going to define this variable, okay? I'm going to let the random variable x be the hours worked per week by a medical resident. All right, and what I want to find, and don't worry about these slides, I'm also going to post these slides to the classroom so you can download them too. I want to find the probability that this medical resident works more than 84 hours per week. Okay, that's what I want to find. So since we know that the hours worked per week are normally distributed, we're going to use our graphing calculators here. All right, so have your graphing calculator handy as we go through this. And the button you're going to want to use, if you had watched the lecture videos that I've done in class or in the Blackboard classroom, you're going to hit second function and you're going to look for this DISTR button. So second function distribution. And you should see all these options. Now I'm curious, did anybody watch the videos and know which one we're always going to use for these type of problems?
Yes.
Which is it?
Normal CDF.
Yeah, the normal CDF option, this one right here, number 2, makes this problem super easy. So everybody go down and click on it, okay? Now, if you have a TI-83, I'll load that up here. If you have a TI-83, when you press this button, second function distribution, normal CDF, you just see this screen here, okay? All right, so if you have the TI-84, it's a little bit easier. TI-83, you have to plug it in. So whenever they ask, oh, I wrote this backwards. Whenever they ask a, I'm sorry, I didn't. Whenever they ask a more than problem, so I want to find the probability that this medical resident works more than 84 hours. The lower bound is that first value. So I want to start at 84. So I'm going to put 84 in here. I'm going to hit enter. When you see the TI-83 here, what you're going to do is you're going to put 84, and then you're going to press the comma button. And I want to keep going. I want everybody who works more than 84 hours. So what you're going to do for the upper here is you're going to put a ridiculous number. You're going to put like 9999, okay? So in the TI-83, you're going to put 9999, comma. Over here, you're going to hit enter. Does anybody remember what the Greek letter mu stood for?
Sample mean.
This, not the sample mean, it's the population mean. But yeah, you're absolutely right. So if you look back at the problem, okay, on average, how many hours per week did they say medical residents work?
84. No, 80.
Yeah, so you're going to put 80 there. Going to hit enter. So then over here, we're going to put 80 as well. And then what did I say the standard deviation was for?
5.5.
Yep. So over here, I'm going to put 5.5. On the TI-83, I'm going to put 5.5. You're going to close the parentheses here. Over here, you're going to go down and hit paste. And you should see this in your calculator for both of them. All right, so the next thing you're going to do is you're going to hit enter. And you should see this. How many people following along were able to get this with their calculator?
Yeah, it's like.
Got it.
Yeah, so guess what? That's just your answer right here. So when you go to type this in, like when you go to submit a quiz or a homework, all you have to do to show your work is literally type in the command that you plugged into your calculator. So we went normal CDF, comma, we started at 84. We put in a ridiculously high number like 99999. The mean was 80. The standard deviation was 5.5. And when you look here, that is 0.2335. And that right there is our answer. Is it pretty easy with the using the calculator?
Yes.
Yeah. How many people have tried it using the normal table and actually writing it out that way? Like using that z-score table. Has anybody tried it that way? Well, if you have, you'll notice that it's like much harder. Like you have to calculate a z-score, you have to go look it up on the table. This calculator, boom, does it for you just like that. All right, so let's try this next one. All right, so the next one says, what is the probability that a randomly selected resident works less than 70 hours per week? So that's the probability that that random medical resident works less than 70 hours. So I have to figure out that. All right, so I'm going to go back to my normal CDF here. Okay, so I'm just going to do this on the TI-84 calculator. So I'm going to hit second function and then go back to DISTR. And what option did I want again?
Normal CDF.
Always going to be the normal CDF. So now here's the thing. I want it to be less than 70. All right, so for my lower value here, I'm going to put a ridiculously low number. Okay, so I'm going to go negative 9999. And then what do you think my upper is going to be here?
70.
Yeah, because I'm telling you to go up to 70. I want everything less than 70. The mean never changes. That's still 80. The standard deviation never changes. That's still 5.5. So when I plug it in, if you have the TI-83, you're going to write it in like this. And this is going to be the answer, 0.0345 when I round it to 4 decimal places. Not too bad?
No, but I did have a quick question.
Of course. Go ahead.
So, like, why are we in, like, wouldn't 0 have worked? Like, what happens if you change the number, or if you put something like, for example, 50 for the lower, or like 40? Like, how does it change?
So it's the actual answer. You won't notice much difference. Sorry for not typing that in. Like, you'll notice if I do that. You don't see much difference at all. Like you have to go out, I don't know, 7, 8 decimal places until you see a difference. It doesn't matter. You just want to put a ridiculously low number relative to the problem. So for the problems that I will ask in this class, you can always use either negative 99999 for the lower or 999 for the upper. But you're right. It doesn't matter basically what number you put in there, as long as it's ridiculous compared to the other values.
We'll never see a problem that's like, because what if it gave us like a range, like they have to work minimum 50 hours, for example? Like, we'll never see a problem like that.
So if I say, what's the probability they work a minimum of 50 hours? That's worded really weird, but a minimum of 50 hours would be that X is greater than 50. So you would put like 50 here, and then you would go 99999 up there. But for this class, because we switched online, I'm not going to ask anything really confusing like that. Like the methods I'm showing you here will be how you will solve them.
Okay, I got it. Thank you.
Okay. Let's try this one. What is the probability that a randomly selected medical resident, now I'm saying works between 70 and 84 hours. So I want to find the probability that that randomly selected medical resident is between 70 and 84. So this is an in between. So when I go to my calculator here, I'm going to go second function DISTR. I'm always going to go to the normal CDF. And now I want to be between 70 and 84. So what do you think my lower value is going to be here if I want to start at 70?
70.
Yeah. And what's my upper going to be?
84.
Yeah. So when you want to be between two numbers, okay, you're going to put the lower number here and the upper value here. So when you go to type this in to show your work, you're going to say I did normal CDF. I started at 70. I went to 84. The mean was 80. The standard deviation was 5.5. And that answer is going to be 0.7319, but when I round it to 4 decimal places, I'll get 0.7320. And that right there will be your answer. So what do you guys think? With the calculator, not too bad?
Yeah, it's pretty straightforward.
Yeah, it's pretty good.
Yeah, so here's what you can do. The way I encourage you to submit like your homeworks and your quizzes going forward is I've attached 2 files. I've attached a PDF and a Word document. I actually think just downloading the Word document and writing in stuff like this is the easiest thing to do.
Okay.
So when you go to submit like your quiz this week, this right here is the only work you're going to need to be able to show. Just you're going to write the probability statement, what you plugged in your calculator, and then the answer. And from that, you should be good. A little less stressful?
Yeah, thank you.
You know what? You're welcome. All right, let's try the question number 2 here. Okay, and this one's a little bit different. Has anybody on the call looked at the lectures under 331 yet, or are you planning to do it a little bit later today?
Yeah, I was gonna do it after this.
Okay.
Yeah, me too.
All right. If you haven't looked at it yet, that's not a problem. I just want to give you a small introduction to how you're going to handle these problems, okay? And to just highlight the key differences, okay, between this problem, question 2, and the problem question 1. So your quiz that's due, that's posted under 4/2 is not related to question 2. It's related to question 1, okay? So you should be able to go after this lecture here and basically do the quiz. This question 2 is what's going to show up on your exam that's coming next week. If you've looked under the tabs that I posted in the classroom under 4/09, you have your first exam that's due. And don't stress, next week, I'm also going to host another one of these lectures, and I'm going to do problems that are just like on your exam. But so this is just kind of a preview for this stuff here. Okay. So question 2 goes like this. The charge life of a certain lithium-ion battery for camcorders is normally distributed. So again, I'm telling you it's normally distributed. And I'm telling you there's a mean of 90 minutes and a standard deviation of 30 minutes. Okay, so just kind of like the previous problem, I tell you it's normally distributed, give you a mean, give you a standard deviation. So this problem looks a little bit different. What is the probability that a random sample of 25 batteries, okay, so I'm telling you a random sample. So here what I'm doing is I'm giving you a sample size, all right, of this type, so of this camcorder battery, has a mean charge life. So I'm asking you the probability the mean charge life is less than 80 minutes. Okay, does this problem seem a little bit different than the first question, question 1? And if so, how is it different?
It's different because instead of taking one sample, we're taking 25 samples.
That's exactly right. If you look here under question 1, it's always like 1 resident. What's the probability that 1 resident works more than 84 hours? This one here, I'm saying, okay, let me take a sample of 25 camcorders, compute the average of those 25 camcorders, and then I want to find the probability that that average is less than 80 minutes. So here's the whole crux of the problem. When I randomly sample 25 camcorders, I have no idea what the average is going to be. So I'm going to define this variable here. I'm going to let X bar be the sample mean charge life from 25 batteries. Okay, so that's my X bar here. What you'll read about this week is there's going to be something called, and when you watch the online lectures, something called the central limit theorem. And what you'll see on your own here, I'm going to call it the CLT, the central limit theorem, tells us the sampling distribution of this X bar of this X bar that we have here will be normal, all right, will be normally distributed. And then what it tells you then is what would the average of the averages be and what would the new standard deviation be for this distribution? And this standard deviation is called the standard error. Okay, so mu sub X bar, it turns out the formula for this, and you'll see this in your lecture this week, is equal to whatever the population mean is. And so looking here, what is the population mean for how long these camcorders will last? Right in the first sentence.
Is it the 90 minutes?
That's exactly right. Okay, so the average of the averages should be 90 minutes. And the only thing, and this is kind of like a preview, the only thing you'll need to do differently for these problems is when you go to compute the standard deviation, whenever there's a sample size, to find the new standard deviation, which we're actually going to call the standard error, is you take the population standard deviation, which was 30 minutes, and you divide it by the square root of the sample size. Okay, so how large was the sample size here? How many camcorders? I just wrote it there for us. Looks like it's 25. So this will now be equal to, sorry about that. So this will now be equal to, you take 30, the square root of 25 is 5, and 30 divided by 5 gets you 6. So this problem now asks, what was the probability that an X bar is less than 80?
I can't see the screen anymore.
Hold on.
Yeah, what happened?
Sorry, I'm new to Zoom. Can you guys see this now?
Yeah, we're good.
Yeah, we're good.
Yep, sorry, my bad. Okay, so the problem goes now, it says, what is the probability that the mean charge life is less than 80 minutes? So I want to find the probability now that X bar is less than 80. So for these problems, you are still going to use your graphing calculator, okay? So load up this graphing calculator again or have it handy with you. So I want to find the probability that the average is less than 80. So what option have we been using under distribution here?
Normal CDF?
Yeah, you're still going to use the normal CDF. Nothing changes about this. So go down to the normal CDF, hit enter. And if you look at the problem here, I want to be less than 80. So if you have a less than problem, the lower value you're going to put is something ridiculous like negative 99999. I want to go up to 80. So my upper here is going to be 80. And then for the mean and standard deviation, you're going to use this value for the mean, which is 90. And for the standard deviation, this is where sometimes people make mistakes with these problems. You do not use this value here. You do not use 30. You use this value that you calculated here, which is 6. So this problem is solved as normal CDF negative 999, comma 80, comma the mean was 90, comma the standard error here was 6. And this problem ends up being 0.0478 when I round it. So the only difference for these problems is right here. The only thing you have to remember, just to boil this down when you go to do these problems, is that whenever you have a sample size here, you're going to take the standard deviation, divide it by the square root of 25, and that's it. Okay, kind of, I know this is a preview and many of you haven't watched the lectures yet, but at least with the calculator here, does it not seem too bad?
Yeah, it's okay.
All right, let's just try this last one then together. All right, what is the probability that a random sample of 25 batteries of this type has a mean charge life? So I want to find the probability that it's between 80 and 95 now. So hopefully you can see how this is going. So this is just going to be normal CDF. I want to be between two values. So we're going to start at 80. We're going to go to 95. The mean was 90. The standard deviation was 6. So I'm going to go second function, distribution, normal CDF, and 80 to 95. The upper 95. The mean is still 90. The standard error is 6. And this is going to be 0.7499 when I round it. Okay? So the trick here is to just always use your calculator. Always, always use your calculator. All right, that's the lecture. So what I'll do here is I'm going to stop the recording, and then I'll take any questions that people want to ask, you know, so it's not recording.